Hi everyone, I'm going to go over two more lectures on cognition this time rather than perception, just to finish off our human factors. In case you thought we were doing a psych degree, this should be the last of them, but they directly relate to what we've been talking about before for information seeking, for how we do data cleaning, how we look at information, how we process information. And so I'm hoping most of this stuff does come in handy. It's coming from the perspective of visual perception, but there's other things we could talk about if we wanted to, if you're interested in. So when we talk about cognition, what we're talking about is how we think through a problem. This is not, our motor abilities or anything like that. We can talk about that if you wanted. This is more how we think and how we reason about data. We're also going to see a little bit more about how we perceive data and how we chunk information. Information chunking is actually an important part because we do not see the world as we saw with perception. We do not see the world like video cameras in our head. We do a lot of, we initially get the image, but it's only a whole bunch of neurons firing, and then we are finding patterns and we're chunking those patterns. And so we're going to look at contour and texture detection and vision now. Then we're going to look at Gestalt Principles, how we actually chunk or break apart a scene. That's very informal compared to a lot of the other psych literature. The Gestalt school of design was actually, it's not initially scientifically or empirically based, other than roughly empirically based, but then it has since been verified afterwards. And then we're going to look at attention and how we can affect visual design that way, and what a gist is, for example, and how we can make memorable content. So, turns out, as we talked about last time, we're very good at edge detection, that where there's a difference between white and black, or two different colors, but particularly for darkness and lightness, we're really good at picking up those edges. What's interesting, though, is we have a bunch of other visual processing afterwards, where if the contours are different, if there's a difference in pattern, or if there's actually a continuation of a particular pattern, we get a different response. So we respond to short little contours, but when you string them all together, some of your higher visual processing functions take over and say, yeah, that is one group. So if I show you a blob, a line, a blob, a line, a blob, a line, you will visualize that as a line or a continuation of all those things. We are designed to find patterns, even if there's not patterns there, which is actually a problem. It's the reason why we have so many weird conspiracy theories about what people see. Because we want to find patterns that are not even there. And it's a problem that you have to make sure when you're talking about a data analysis that people are not seeing things that are not there. It's very easy to have a lie factor, which we'll talk about soon. So if I see these shapes, no matter what, notice I will automatically see this outline of a particular dog, which allows me to say that's this. So this is a generalized contour for all these different shapes, no matter what kind of system you have. But notice there's a difference in the pattern between the stucco dog, if you will, the black and white television dog, and the tiles in the background, or just the outline, or the black silhouette on a white background, or the actual dog, or different colors. We're designed to find where the differences are, get a general shape, and then identify the things based on shape, because that's how we visually process our world. As a result, though, it means we will see things that are not necessarily there. But it also means we detect textures, and differences of textures also tell us where things are. So the granularity or the size of the granules of the texture, you see two different circles. The orientation of the circles, you see two different circles. Whether you want to or not, you'll see that. Or if the amount of contrast that we have, you'll see two different circles. If you do not have that difference, you won't see anything. So my son is playing Dungeons and Dragons right now, and he made the background, the outline of the dungeon he's trying to draw is brick. I think it's stone, and the inside part is brick, and they're very different colors. And he thought, hey, that looks great, right? He liked having the nice granularity and stuff. And then we printed it on black and white, and then he said, I can't see my dungeon anymore. I see the outline, but it's really hard to see. Which I said, hey, I'm going to be teaching a lecture on that in about 2 days' time from now. about granularity, because what you see with his dungeon, I probably can try and give you the actual dungeon if you wanted to, I have it on my drive, is you have a brick background for the main floor, and then the outside is stone. They all have about the right same size texture. They're both a bunch of little circles to identify the shape. But as a result, when you printed it into black and white, there is no difference between, or there's minimal difference in the texture between the two, and you don't see what the shape of the dungeon is anymore. So these kinds of things are really easy, right? If I have different sizes, different orientations, different level of clarity, different curvature, for example, really easy to find in texture difference. Not so much, right? Just orientation of a particular shape that is not necessarily a particular, I think there's a line in the center. Yeah, there's a line in the center here, but notice they're completely different shapes, but they have that same up and down, left and right orientation. This is much harder. This shape over here on the right hand side is much harder to see than the shapes on the left. If I'm trying to pull apart the difference of texture for, oh yeah, there you go. I notice I have a crossover effect that I can identify the red versus the green very easily, but this is green squares, red circles, and red squares, green circles, and where that line is really hard to see because of this sort of the effect of the color impacting. It's a secondary effect, but you can't tease apart these two different patterns because there's multiple different dimensions changing at the same time. But, so text on background containing similar feature elements will be very difficult to read even though the background is different. The feature elements are relatively the same. There's a lot of curvature, there's a lot of straight lines, much like text. If I blur the background, the more background differs from the element granularity, the feature in feature similarity and the overall contrast, the easier the text will be to read. Much easier. And low contrast backgrounds interfere less. This is why we have different things, not just the color, but we also want to have differences of brightness and lightness. The blue background is lighter, and so we can find the bounds or the edges for the N and the D and all these text features easier than with a darker background because of the orange. And we have a darker background with a lot of clarity with the same shapes. We have a huge amount of difficulty reading that. And these are fundamentals for graphic design, but they also impact visualizations and how we design an interface. How your projects should be looking, in so you don't make a PowerPoint presentation with a background, a particular background color or pattern, and then try and put text on top of it. If you see a bad PowerPoint presentation that you can't read, it's probably this, or one of the causes might be this. So here are the Gestalt principles. Here's just one of them, similarity. Everyone here, when they look at this, they see a group of squares and a group of circles. Now you see a group on the left and a group on the right. There's still squares and circles, but you group it as group on the left, group on the right. That you have top alignment, bottom alignment, left alignment, right alignment, for example. And now you see 5 different groups. All the squares, all the circles, all the orientation gets completely, changed by just putting a line connecting things. I will see this as one chunk. Not this anymore, all the way ahead orientation. That line connects things automatically. I put a square around it. Now I have something else. These are part of a group. This stuff is all part of one group. This is outside of that group. Plus, we know there's some connection between these two. We don't know what this is. This is just random shapes that I'm putting up on the screen, but everybody looks at it the same way. That's what's interesting about Gestalt principle. Now, Gestalt actually means the word good form. I do believe it's German, but it means good form. And so there's also, do I have a common fate one? Here we go. There we go. That's a group. You can't not see it. All right. Now, if I move those at the same time, I don't have what moving at the same time. If both of those chunks moved at the same time, they would be considered part of a group, despite the fact they're spatially separated. what's, oh, good Gestalt is good. Gestalt means form. So what this means is when we're designing things, when we put a connection between two items, it means there's a connection and we link these two together. If I encapsulate something or enclose something, I will consider them as part of a group. Common color regions, common textures, or just a line around it, all tell me how to group things together. It's how my eye naturally works. If I put things together in proximity, I don't need lines anymore. At least in this case, I will see A, B, C, and F and E as two different groups. I will also see them as two different groups based on the color. When I align them, I automatically assume there's an ordering effect, whether I want to or not. If I move them at the same time, I will see them as groups. All of this, so here's here's similarity. What is a similarity though? I actually have two different things going on here, by the way. Similarity can be done by the shape. It can also be done by the size. I can group them by small objects. You can see that. Group them by large objects. You can see, or group them by shape. You can see that. Proximity tells me to group things. Alignment tells me to group things. I will see two different groups here, just how everything is aligned together. And also, by the way, because these are close together, I will see rows, and the rows will be considered, each element on the row will be considered closer or more related. I see, at least for me, I see the columns more closely related because the distance between the elements in the columns is closer in terms of alignment, or in terms of proximity. So we can group by similarity, connectedness, closure, which we already looked at, and this is where it comes up. Here is a black and white scatter plot with a bunch of different, dots. If I just use shape, only one of these dimensions, try and trace the pattern. What am I seeing with the scatter plot? Now, if I use connectedness, so that's just purely based on similarity, right? Can I follow this based on just similarity? Now, what am I using here for Gestalt principles? I have connectedness, I have similarity, so my dots are different than my squares. The connectedness is the lines. I also have closure. This is another principle we didn't quite talk about, but you will naturally want to connect this square and this square via a line. Let me see here. Completeness, it should be, but closure. Okay. You will automatically, not encapsulation, I guess, but you will automatically want to connect this node and this node, these two elements together. There is no line connecting these two. There's two line segments, and there's sort of this gap, and you will automatically see the pattern because you're designed to. But the key is if you can play with how people perceive things, you do not actually have to actually connect these two dots in order to imply or convey the connection. You will do it naturally. So you can remove a lot of the ink you'd be putting on the page. You can remove a lot of the extra, annotations and the labeling and all this kind of stuff if you just design with with a purpose. Just choosing a different color will make something pop out for the user if you want to convey it. And not just, so you don't have to sort of, it's the opposite of my See You Learn page where I just have a whole bunch of stuff and there's so much stuff that I've presented to you guys, you don't know what to necessarily look at. The key would be is if I was able to spend more time to organize all that information and just chunked it into groups, everyone knows exactly where to go at any given time to find the information that they're looking for. Right? That's ideally what I should be doing. It just takes a lot of effort to organize things, right? That's why you organize your rooms the way you do, because you chunk things in a particular way, and you like similar things being put together so you know where to find them. Same thing with visual perception. By the way, closure just allows you to do a lot of interesting things, like everyone here, invariably, unless you have some kind of, I don't think anyone has expressed that they have some kind of visual impairment for this kind of thing, you will see a triangle there. There's no triangle. There's like 3 Pac-Man shapes there, essentially, but there's no triangle. Your body will fill in a triangle whether you want to or not, because it's it's what's useful for you perceiving your world. There is no square there. There's no circle there. There's like a Pac-Man-like thing and a line going around it, but it's line going around it, right? But this is not necessarily a square and a circle, but you will read between the lines. And giving this allows you to simplify what you're presenting to people without having to just get all the details. WOF, that's not a panda. That's not a square. That's not a cube, in space. You can do entire books, the black cat and white cat. I mean, you automatically see cats there. And here's symmetry where you will try and see things. You like symmetry. People tend to like symmetry, and they will see things based on the symmetry. Multi-stability, though, is, I don't know how many people have looked at this thing before. How many people see a cup or goblet, chalice, whatever you want to call it, and how many people see 2 faces pointing to each other? This is one of those weird things where you can see the 2 faces and then see the goblet, and then see the 2 faces, and then see the goblet. You can't see both at the same time, but you can switch between the 2. And it's an interesting psychological factor. We also like things that are aligned. So you will see all of these things, these circles, they're all in alignment with one another. This forms one unit. This forms one unit. Why? Because you want to align things with some particular rhyme or reason. So, similarly, in terms of similarity, things that look like each other are related. Things that are close to each other are related. Things that are connected are related. Things that you will automatically fill in things to try and make simple shapes. You will try and complete shapes that aren't there, even if they're not there, because that's what we want to see. Figures, often elements are perceived as either the figures or the background, so things in the background are not the thing you're paying attention to if that is how you perceive a graphic, for example. You do not look at the axis as the main thing. You look at the dots on a scatter plot. And things that are moving in the same direction, if you have movement especially, but even if it's implied movement, are perceived as one unit. And this is where it comes in. If I'm trying to show that 2 concepts are related, I encapsulate them, or they're part of a common thing. Overlapping concepts. This is what a Venn diagram is, right? I have 2 different sets. I overlap them. That's the things that are in common between the 2 sets. And everyone sees it. I can see that related across groups. If I show a connection, a line between things, I will see a connection or a relationship. And I can have multiple different relationships. So here is a tree data structure with presuming 3 completely different types of data based off the shape and the color being different. The star, the circle, the square, with also color changing as well. But I also have a hierarchy that this is related to these. These are all related to one another. They're connected to each other. These green circles are connected to each other, but they're all somehow connected to this star. And you can convey information, and each of the lines on a line graph can be changed, and they can convey things. So here's a Venn diagram for overlapping concepts. Here's what's called a tree map for overlapping concepts. Things that are all in orange are related to one another. Saharan Africa would be there. This is Asia. This is for this. So this is for the AIDS epidemic, and this, what is red? I think this might be just in general. It allows you to, everything within a bounded area are related to all the other things. All the things in the bounded area are related to each other. And so a tree map gives you a space filling algorithm to show a hierarchy of information, like a tree, but everything bounded within an area are, related to each other based off of this whole nesting. And if I show connections, for example, like I select a scatter plot, a series of points in a scatter plot, I could have a line going from one of my data items to an image in Flickr and to a bunch of text and the particular words, a Peugeot, the kind of car that they're showing there, all the different Peugeots for all the different articles. So I chose Peugeot, I see a picture of it, I see where the word Peugeot shows up in all these in all this text. That would be these purple things. The fuchsia, I guess, color here is for Renault, and Chryslers are in brown. If you show connections between them, if all the items change color at the same time when you click them, or if you select a bunch of items and those same items are highlighted in multiple different visualizations at the same time, I have a connectivity, I have the common fate of how my data is looking, and I will automatically group them together. This is when we're going to go over design principles. You'll see this again and again and again. Gestalt principles are a nice, quick, shorthand way of looking at this. By the way, how you attenuate two different patterns depends on what you're looking at. I can look at any one of those levels all at the same time and tease apart what they are. So, what is the top one? What is the gray elements in there? You should see a triangle plus, I don't actually see that next one. It looks like an O or a circle, a square, circle, X plus, and a heart that's hand drawn. We have 3.14159265358 for the yellow text, and feature level tuning can allow us to attend to different layers of information. And then I have a line, all based on color and the level of and the texture that I'm seeing here. So I might have to take a little bit of a break here, I think. Let me just try and finish off some of this here. When we have, for graphical codes, shapes are really good for identifying particular objects, entities, particular nodes, and they're defined by closed contours, their kind of texture, color, shading. Spatial ordering tells me order of information, and allows me to, so there's a sort of a left to right. This is purely sort of Western culture influence on this one. A lot of cultures that read right to left may not share this particular pattern. It's culturally dependent. Just like the color green is considered good in North America, it is not in many other countries, including China, for example. Green is not traditionally a good color. Red is a bad color in North America. It's an extremely good color in traditional Chinese culture. Right? If you go to a Chinese wedding, the bride is wearing red at some point in time, or at least traditionally. Right? Proximity allows me to show similar concepts. Same things with the same shape, color, and texture. Say these are related items. I can say when things are grouped together by encapsulation. I can use the size of a graphical object, the height of a graphical object, to tell me how things are working. But the height and the size tell me magnitude, quantity, and importance. If I have things that are connected by a contour, they're related. The thickness of the connection is how strong the relationship is. The texture or the connection tells me the type of relationship. It's categorical data. If it's enclosed, it says there's some commonality between things. Nested regions show that there's a hierarchy. An attachment, just attaching items, tells me that there's parts that are conceptual structure there and they're connected together. So when we come back next time, we're going to look at cognition once again with some visual processing of how we break down problems and how we naturally come to certain conclusions about our data. Okay, thank you very much, and I'll talk to you guys soon.